And what is the paper about? What is the motivation behind this paper? Well, in recent days we've been seeing a growing concern of global warming, and considering that approximately 90% of vehicle CO2 emissions from automobiles, there has been a growing tendency in the automobile industry to produce high-strength lightweight parts as part of an effort to reduce automobiles' weight and reduce their fuel consumption. Being so that according to our article, for approximately 100 kilograms reduction in weight, we have a 1 kilometer per liter increase in vehicle autonomy. And in contrast with the use of high-strength lightweight parts with aluminum, magnesium, and carbon fiber reinforced polymers, this paper studies the use of lower cost, high-strength steels fabricated by this hot stamping process. And you may be wondering, what is hot stamping? Well, the word stamping means pressing against a die, or a mold, or what we will call in Portuguese, mold. And being a process that occurs at high temperature, we have a high formability, which implies a lower tension during the process. As you guys can see here in this image, we have an example of this hot stamping process.
So this process causes a change on the microscopic structure on element base. So this occurs because we have what we call the transport mechanism. So now I will talk about the article. Cyclone steels with low molybdenum content were widely researched in the 1980s, but with the content limited to 0.5%. Studies with the content greater than 0.5 content were conducted, but under cycling conditions that are not usual to the PM industry. So in this article, the authors used the powders with the content molybdenum until 3.5%, and then the focus of this work is to determine the possibility of the use of these new powders and at lower cycling temperatures, but by adding carbon for different applications.
Well, good morning for you all. I'm going to be sincere with all of you that are here, and I'm sorry for the English, this time is actually difficult, but here we go. So, I can be here and actually show to all of you a bunch of numbers, a bunch of graphs, a bunch of images, and I will be sincere with you, you will be sincere with me. I know you will forget by the moment that you pass that number. So, what I need you is your attention for 6 minutes. I have 6 minutes. I will talk about process, yes, I will, but I will not talk about the specificities of the process, because I know you will forget. If you want to know the specificities of the process, if you want to know the graphs, the math, the numbers, you can, but not today. Today I have a message, and I need you to pay attention, and I need, in the end of this presentation, to talk about this message. So, we are going to talk about the transformational steel. Murilo already told us what we will do with AHSS, Advanced High Stainless Steel. Already we know why we use it and how we use it. What I am here supposed to say is what we can do to transform steel into normal steel. HSSS is what I want to use. And transforming steel is talk about future. Why? Because here on Earth, we already know the materials that we have at our disposal. But here on Earth, we are able to change these materials, change the properties in the way that we can use and use in the way that we want to. So let's start. First of all, we need to understand why HSS is so important. The first thing that I want to say, of course, it has exceptional strength and adaptability. Yes, it do. But why it does? Because of the process that we make in the material. And now we are, of course, talking about processing. And three processes is the most important here. The first of them is annealing. Annealing is a heat treatment process, and it's
any implants, so we can analyze the natural behavior of the femur. The second one was implanted with DCP, dynamic compression plate of stainless steel. And the third one was prepared with coaxial cracks so that we can study the impact resistance under sudden impact loads. Two kinds of tests were made. The first one, the impact test. The specimens were taken from the distal proximal middle regions. Some of them were not, and some were not. They are tested in a low velocity pendulum impact test machine with 147.15 newtons.
There are two different wear resisting tests. First one is with a wheel and some blades. The wheel passes through a mixture of sand and water, and this mixture goes between the sample and the wheel. So the wear resistance is made like this. The wear resistance test is made like this. And the second one is with sand. That is in a compartment above the sample. Then it's introduced using a tube. This tube goes between the sample and the rubber wheel. So the wheel turns and it makes this wear resistance test.
Good.